नमस्कार बच्चों, मेरा नाम धन्या और आज हम लोग लेसन 3 केमिस्ट्री लेसन 3 का कुछ पास्ट पेपर नीट एंड जेईई पास्ट पेपर क्वेश्चंस डिस्कस करने वाले हैं. सो क्लासिफिकेशन ऑफ एलिमेंट्स. ओके, सो this is the first and the second question. Please take a screenshot of the questions. Okay, so here the first question, they say which of the statements are true. Okay, so they have given you 5 statements. Unlike gallium that has a very high melting point, cesium has a very low melting point. Okay, then on Pauling scale, the electronegativity values of sodium and chlorine are not the same. Argon, potassium ion, chloride ion, and calcium ion and sulfide ions are all isoelectronic, having the same number of electrons. Then the correct order of first ionization enthalpy. Okay, and they have given the order. Then the atomic radius of cesium is greater than that of lithium and rubidium. Okay, so these are the statements given. Okay, so you have to tell which of the statements is true. Okay, so sharing the screen, sharing the whiteboard. Okay, students, we are discussing the past paper question. The first question, we have a set of statements. We have to tell which of them is true. Okay, so the first statement is both gallium, unlike gallium that has a very high melting point, cesium has low melting point. In fact, both of them have low melting points. So statement A is false. Okay. The B statement, on a Pauling scale, the electronegativity value of nitrogen and chlorine are not the same. In fact, they are the same. It's 3. So second statement is also false. That's why some electronegativity values you have to memorize. Okay. So they ask questions like this. Then we already discussed isoelectronic species means they have the same number of electrons. Okay. So some ions and atoms they have given and they are saying that they are isoelectronic. Okay. So here S2 minus. Isoelectronic means they have the same number of electrons. So argon has 18 electron. Potassium is atomic number is 19. When it loses 1 electron, it becomes K plus ion. It has 18 electron. Chlorine is atomic number is 17. Chloride minus means it's gaining 1 electron, so it becomes 18. Calcium, the atomic number is 20, but when it loses 2 electrons to become calcium 2 plus ion, 18. Sulfur is 16, the atomic number. When it gains 2 electrons, it becomes sulfide 2 minus. The atomic number is, the number of protons is, or number of electrons is 18. Number of electrons is 18, so it's isoelectronic. So C statement is correct. Okay, coming to the D statement, the correct order of first ionization enthalpy. Now you know that they are in the same period. Okay, Mg, aluminium, silicon, they are in the same period, and along the period, the ionization energy increases. So over here, this is wrong because silicon is greater than so our first silicon, so across the period, it increases, ionization energy increases. But if you see the configuration of magnesium and aluminium, magnesium atomic number is 12. So 1s2, 2s2, 2p6, 3s2. Okay, but in case of aluminium, 1s2, 2s2, 2p6, 3s2, 3p1. It is easier to lose electron from aluminium, but in case of magnesium, it has fully filled s orbitals. So it is difficult to remove the electron from magnesium compared to aluminium. So definitely magnesium will be having a higher ionization enthalpy than aluminium. Okay, so this is the small discrepancy. So statement D is also wrong. Coming to the E statement. In E statement, Atomic radius of cesium is greater than that of lithium and rubidium. So you know, as you're coming down, the radius is increasing. Radius increases. So you have cesium down the group, and lithium and rubidium are above the group. So definitely this statement is correct. So our answer is C and E statements are correct, which corresponds to option D. Okay. So this is the first question. Okay, I hope this is clear. So when these type of options come, you have to go one by one. Okay, coming to the next question. Question number 2. And question number 2, you have some configurations that are given, and you have to tell which among the following electronic configuration belong to main group elements. Now, students, the main group elements are group 1, group 2, and then from group 13 to 18. The groups that are in between 3 to 12, they are the D block elements. So we have group 1, 2, and then group from 13 to 18. These are the main groups. Okay, that's the main group elements. Okay, so if they tell you group, main group, that is, these are the groups. So group 1, group 2, group 13, and group 13 to group 18. Okay. Now, you have the first one, sodium. How do we know that's its sodium? Because neon is 10, 10 plus 1, 11. Okay, so this, and obviously this is in group 1 because they have told this is 3s1. So this is in group 1. Okay, group number, how do we decide where the valence electron goes? So this is in group 1. So this is the main group element. What about B? Argon is 18. Then we have 3d3, 4s2. Okay, here the d orbitals are getting filled up. So this is D group, D block. Or you can find out from n plus L rule also, where is the last electron going. So 3 plus 2, that is 5. Here 4 plus 0, 4. So definitely the d orbitals are getting filled. So definitely it's a D block element. So this is not in our main group. Okay. Coming to C, we have krypton, 4d10, 5s2, and 5p5. Here obviously the p orbitals are getting filled up. So this is a p block element. Right. Now here, D is argon, 3d10, 4s1. Here, in this case, you have to be careful because here argon is 18, and here when the d orbitals are fully filled and you have this configuration D10 and 4s1, please be careful and check whether it is a D block element or not, because we have 18 plus 10 plus 1, which is 29, and 29 copper. We have done practice so many times, it's copper, right? So definitely this is a D block element. Okay, or if you have a doubt, you can always check with the N plus L rule. 3 plus 2, 5. 4 plus 0, 4. Definitely the electrons are filling the D subshell. Okay, so that way also you can confirm. So definitely it's a D block element. Okay, now coming to the E option. E option, if you see the F orbitals coming, the F subshells coming, you have to check the range from 51 to 57 to 71, 89 to 103. This is the range of the F block element. Okay, now in this case, the Rn, the atomic number of Rn is 86. Okay, radon. This is radon and it is 86. Okay, and then the rest of the atomic number and rest of the electrons, if you add up 2 plus 2, that comes to 90. So definitely it's falling in this range. So definitely it's an F block element. Okay, so that's why you have to remember this range. If any F subshell comes, just add up the number of electrons and check if it's coming in this range or not. If it's coming in this range, that means it's an F block element, so that's not in the main group. So what is our answer? Our answer is A, C. Main groups are A and C only. That corresponds to our D option. Okay, so this is how we find out our main groups. Okay, so main group is from 13 to 18 and also group 1 and 2. So we have to basically check if it's an S block element and P block element or not. If it's D and F, that's not main group element. Okay, so this was the first two answers. I hope it's clear. Coming to the third question, I'll just share the screen. Coming to the next set of questions. Okay. Please take a screenshot. In the next question, if you see, the correct decreasing order of atomic radii. Okay, so they have given a set of option. Okay, so just sharing the whiteboard. So we are doing the third question. So in the third question, we have lithium, beryllium, boron, and carbon. Okay. So this is along the period. So along the period, the nuclear charge increases, the radius is becoming lesser. So lithium is greater in radius than beryllium. And then after that is boron, and then is carbon. Okay, it's beryllium, boron, and so this is the range. Okay, students, the next question. You have been given some elements and you have to arrange the elements in increasing order of their electronegativity. Okay, so you have nitrogen, you have oxygen, fluorine, carbon, and silicon. And the values that that is given in the Pauling scale, according to that, we have learned that silicon has the least, then it's less than carbon, then it's less than nitrogen, is less than oxygen, is less than fluorine. Fluorine has the highest, right? And some of the values that I had given. So according to this, we can arrange like this. So A is the correct option. So that's why some values of the values of electronegativities of some elements is you have to memorize so that you can answer these kinds of questions. Okay. Moving further to the fifth question. In the fifth question, you have the correct sequence given below containing neutral, acidic, and basic, and amphoteric. Oxides. Okay, and you know that non-metal oxides are acidic, non-metal oxides are acidic, metal oxides are basic, and there are some neutral oxides that you just have to memorize, like carbon monoxide, nitrogen monoxide. Okay, these are all neutral. It's not carbon dioxide, carbon monoxide. Okay, and amphoteric is they show both acidic and basic behavior. Okay, so one is zinc oxide and one is aluminum oxide. So just memorize one or two of them so it is easier. So we have NO is neutral. Then acidic is carbon dioxide. Carbon dioxide is acidic. Then we have basic. Basic is calcium oxide. Metal oxide is basic in nature. Then we have zinc oxide is amphoteric in nature. One more example is there, aluminum oxide. So this is the order. Okay, so our answer is D option. So this is our correct answer. I hope this is clear. Okay, so neutral, these are some of the examples. Please note down carbon monoxide, NO, these are some neutral oxides. Okay, I hope this is clear. Neutral means they are neither acidic nor basic. Okay, so that's the criteria. Okay. Okay, students, the next set of questions to the fifth one. Sorry, sixth one. Sixth and seventh. Okay, please take a screenshot of the sixth and the seventh. Okay, here also the first question about the order of first ionization enthalpy. Okay, now here, just sharing this whiteboard. Sixth one, you have been given some elements. You have to arrange them according to the ionization enthalpy or ionization energy. Okay, so you have carbon, you have oxygen, you have nitrogen, you have fluorine, right? Or the other way around. First is in the period. You have nitrogen, oxygen, and fluorine, right? Now, for oxygen, for nitrogen, it is along the period. What happens to the ionization energy? Ionization energy increases, but over here, nitrogen, 1s2, 2s2, 2p, 3. What kind of configuration does it have? It's a half-filled stable configuration, right? So carbon, it will be lesser because as you go along the period, the ionization energy gradually increases. That will be lesser than nitrogen or fluorine, oxygen. It will be oxygen because nitrogen will have a higher ionization energy. Why a higher ionization energy? Because it is stable, half-filled configuration. So that will be lesser than nitrogen. That will be lesser than fluorine. So we have our D option. So whenever this type of question is given, just write down the order along the period and then just check out for stable configurations. Okay. Coming to the seventh question. Seventh question is decrease in size from left to right in actinoid series is greater than the gradual than that in lanthanoid series. Now, students, you know that the lanthanoid contraction is due to the diffused 4f orbital. Same way, 5f orbital also are diffused or they have poor shielding effect. Okay, poor shielding effect. Okay, now if they have poor shielding effect, the size decreases, right? They are not able to shield the outer electrons from the nucleus, and therefore there is a gradual decrease in radii. So if we compare 4f and 5f, 4f is even more poor shielding effect than 4f. Sorry, 5f has the more poor shielding effect than 4f. So that's why there is more decrease in size in actinoids than lanthanoids. Okay, so here, what reason will be correct? The D reason will be correct. That means 5F has poor shielding effect, even more poor than the 4F. That is why there is a decrease in size in actinoid series. Actinoid series, the decrease in size is in actinoid series is greater than the decrease in size of lanthanide series. Why? Because of the more poor shielding effect of 5F compared to 4F. Okay, so I hope this is clear. Now, coming to the next set of questions. The next set of questions, please take a screenshot of the next set of questions. So, as you can see, I have given the year also, okay, of all these questions. I've tried to include the different type of questions, okay. Okay, the first question, question number 8. If you see, the element E has ionization enthalpy value is given. Now this E reacts with the elements A, B, C, and D with electron gain enthalpy values. Okay, they have given the values. The correct order of the product formed in terms of ionic character is. Okay, so we're just sharing the whiteboard. Okay, students, question number 8. They have given these values of for E, it is ionization energy, and for A, B, C, and D, it is electron gain enthalpy. So, electron gain enthalpy. So, A has been given a value of minus 328, B is given as 349, C is given as minus 325, and D is given as minus 295 kilojoules per mole, or all is in kilojoules per mole. Okay, so this is electron gain enthalpy. Electron gain enthalpy. Now, students, they have said the correct order of the products formed in terms of ionic character. Now, ionic character is more. Ionic character, it's a simple thing. Ionic character is more if electron gain enthalpy, the magnitude is more. Okay, so if that is the case, then who has the magnitude wise, who has higher electron gain enthalpy? B, the product B. So definitely EB formed will be having more ionic character than, which is the next one in terms of magnitude? A, right? So EA. Then we have C, then we have ED. Okay, so this is the order. Okay, so this is the order that corresponds to third one. Third option is correct. Okay, so electron gain enthalpy, if it is given, higher the magnitude, more is the ionic character. I hope this is clear. Coming to the next question, question number 9. In question number 9, the type of oxide formed by elements among lithium, sodium, beryllium, magnesium, boron, and aluminum. Okay, so these are some elements that are given that has the least atomic radius. Okay, and they have given some oxides. Okay, now over here, the type of oxides formed by the elements that has the least atomic radius. So you can see from here, if you see lithium, sodium, beryllium, magnesium, boron, and aluminum, right? So they have given two different periods. Okay, now if you go from left to right, what happens to the radii? Size decreases. And at the same time, if you're coming down the group, radius increases. So which element has the smaller radius? If you compare both of them, because they have given two different periods, okay, and at the same time two different groups. So if you go from left to right, radius is decreasing. Okay, so that means we can look out for boron and aluminum. But as you're coming down, the radius increases. So we rule out aluminum, it is boron. So definitely it is the second option, B2O3. The oxide of boron has a smaller radius. Okay. Now, also boron has a smaller size, and the covalent bond formed between boron and oxygen, it is very strong. Okay. Now coming to the next question. I hope this is clear. Now, coming to the next question, question number 10. The incorrect decreasing order of atomic radii. The incorrect one. Over here, okay, the students, this is the first option. which is correct because we have silicon, phosphorus, we have chlorine, and then on top of chlorine, we have fluorine. So this option is correct, but they have not asked for the correct option. They have asked for the wrong option right now. If we check the second option, if we have beryllium, magnesium, aluminium, and silicon. Okay, so beryllium is on top, magnesium, then we have aluminium, then we have silicon. So definitely as you're coming down, the radius is increasing, right? So definitely beryllium is less than magnesium, which is greater than aluminium. Which is greater than silicon, because along the period it is increasing. Okay, so here they have done the order as beryllium is greater than magnesium. This is wrong option. Okay, so second option is wrong option. Okay, I hope this is clear. So our answer is the second answer. Okay. Now students, coming to the next question, question number 11. Now students, coming to the 11th question. Now, number of elements from the following that cannot form compounds with valencies which match their respective group valency. Now, let me just tell you what is group valency. Group valency is nothing but the number of electrons in the valence shell or outer shell. And how many bonds they will form using those electrons. Okay, so basically you have to check how many electrons are there in the outermost shell or whether all of them are used up to form the bonds. If all of them are used up, then that means they match the group valency. If not, they are not matching the group valency. Okay, for example, boron. If we talk about boron, the atomic number is 5, so 2, 3. So we just write down the outermost electrons. Okay, so outermost electrons is, all the 3 outermost electrons is used up. So BF3. Okay, so that means boron is matching. Okay, so all the 3 electrons at the outermost shell is used up to form the bonds. So the question is which of the following cannot form compounds that matches the group valency. So BF is okay for us. Okay. Second one is carbon. Carbon is 2, 4. That means 4 electrons in the outermost shell. So carbon forms compounds like methane. So all the 4 electrons are used up to form the bonds. Okay. So here, the next one is nitrogen. Nitrogen, there are 5 electrons in the outermost shell, right? So 1, 2, 3, 4, 5. Now, all the 5 electrons for nitrogen is not used up. For nitrogen, all the 5 electrons are not used up. Okay, so here, according to this, nitrogen should have a valency of 5, but all the 5 electrons are not used up. Only maybe we will see ammonia. Okay, that means only 3 bonds are used up. So that means for nitrogen, the group valency is not matching up the number of electrons in the outermost shell. So our first answer is nitrogen. Okay, but we have to check for the others also. One answer is nitrogen. What about sulfur? Sulfur is 2, 6. So 1, 2, 3, 4, 5, 6. So it forms compounds like SF6, So that means all the 6 electrons are used up to form bonds. Okay, so that means for sulfur also it is matching. Next one is phosphorus. Phosphorus is 5 in the outermost shell. 1, 2, 3, 4, 5. Okay, so it forms compounds like PCl5. So that means all the 5 electrons are used up to form the bonds. Then we have oxygen. Oxygen has 6 electrons in the outermost shell. 1, 2, 3, 4, 5, 6. Now, there is no compounds in which the oxygen is using all the 6 electrons. So oxygen is also not matching. They cannot form a compound where it is using up all the electrons. Okay, so both oxygen and nitrogen, you can see both are very small elements. Okay, so they cannot use up all the electrons to form the bonds, because if they use up all the electrons, then there can be chances of repulsion between the electrons. Okay, then I have aluminium. Aluminium, the outer electrons, there are 3, and it uses all the electrons to form bonds, AlCl3. Aluminium chloride. So aluminium is also matching. Then I have silicon. Silicon has 4 electrons in the outermost shell. Silicon uses all the electrons to form the bonds. Okay, so here nitrogen and oxygen is not matching. There is one more element left, fluorine. Fluorine. It has 7 electrons in the outermost shell. There is no compound where F uses all the electrons. So because of the small shape or small size, already it has a small size. Okay, so there is chances of repulsion. So fluorine also is not matching. So what is our answer? Nitrogen, oxygen, and fluorine. So that means our answer is 2. That means in the second option, we have 3 elements. So how many elements are there? Nitrogen, oxygen, and fluorine, 3 elements. That is not matching with the group valency. Okay, so this was another question. Now I'll share the screen for the next set of questions. So this was the 11th question, 11th one. Okay, so please take a screenshot of the rest and next set of questions. This is from 2024. The 12th one. Okay, so in the 12th question, they have given some statements and you have to tell the statements whether they are correct or not. The first statement is the correct order of first ionization enthalpy is sodium less than lithium, less than chlorine, less than fluorine. Okay. In the second statement, the correct order for the negative electron enthalpy values, sodium less than lithium, less than fluorine, less than chlorine. Okay, so you have to choose which is correct or wrong. Okay, so I'll just share the whiteboard. Okay, students, the 12th question, they have given these informations. Ionization energy, okay, for sodium, lithium, chlorine, and fluorine. Okay, so this is the order. Okay, now this is the statement 1, and this is statement 2 about ionization energy. Let's go one by one. Okay, for ionization energy, as you know, down the group, what is happening? Ionization energy. as you're coming down the group, what is happening to the ionization energy? Decreases. And as you're coming across the period, it is increases. Right? Increases. So definitely down the group, because it is decreasing. So that means sodium is less than lithium. Here, chlorine is less than fluorine. And across the period, because it is increasing, chlorine will have higher than lithium. So this is our order. So this is statement 1, which is correct. So ionization energy is becoming lesser down the group. So that's why sodium is lesser than that of lithium. Chlorine is lesser than that of fluorine. And across the period, what is happening to ionization energy? It is increasing. So we place the order like this. So this is the correct order as given in the question. Okay. Coming to electron gain enthalpy. Okay. Here, that also follows the same trend. As you're coming down, what is happening? It is increasing. Sorry, it is decreasing. Same trend. As you're coming down, it is decreasing. And across the period, it is increasing. Okay, increasing. So that means sodium, the first group, sodium is less than that of lithium. Okay, in group 7, the actual, the expected trend should be that chlorine is less than fluorine. Chlorine is less than fluorine. But we have learned in one of the videos that because of the small size, very, very small size, the accepting electrons is very difficult, because when the electrons are accepted, there will be repulsion between the electrons. So that is why electron gain enthalpy of fluorine is less than that of fluorine. Okay, so there's a small change in this order. The electron gain enthalpy of fluorine is greater than that of, or the electron gain enthalpy of chlorine is greater than that of fluorine. Okay, so let's rearrange this. For group 1, it is the same. Sodium is less than lithium. But for group 7, it is chlorine less than that of fluorine. Okay, so this is the order for statement 2 for electron gain enthalpy. What is the reason for this change? Because fluorine has a small size compared to that of chlorine. Okay, so statement 2 that's given in the question is wrong. So our answer is 4. Statement 1 is right. Statement 2 is wrong. Okay. Now, moving on to the next question. We have question number 13. In question number 13, the electron affinity values are -4. Okay, so there are a set of reactions given. So it is negative for which all? Beryllium is giving you beryllium ion. Nitrogen is giving you N- ion. Oxygen is giving you oxygen 2- ion. Sodium is giving you sodium -ion. And aluminium is giving you aluminium -ion. Okay, so you have to tell electron affinity is negative for which all? Electron affinity. Okay. Now, over here, for beryllium. So we will talk about electron affinity. We will talk about electron gain enthalpy. Okay. Now, for the first one, A, beryllium. The configuration is 1s2, 2s2. Okay, so it's fully filled, right? So accepting more electrons is very difficult. So we have to give energy. So electron affinity is negative. Okay, so electron affinity. So I don't think we have to talk about the electron gain enthalpy. It will be more confusing. You know that just to remind you, if electron affinity is negative, electron gain enthalpy is positive. Okay, so just remember that. Okay, now second one is nitrogen. Nitrogen is 1s2, 2s2, 2p3. Again, this is already stable, half filled. So electron affinity is negative. Adding more electrons is difficult, right? Then question number C, that is third reaction is oxygen. It is 1s2, 2s2, 2p4. Okay, now in this case, oxygen will accept one electron and become oxygen minus, right? Now, oxygen minus will accept one more electron to give oxygen 2 minus. While forming the oxide ion, 2 minus ion, and this is our reaction, it's a polyvalent ion, okay? And we studied that when polyvalent anion is formed, O2 minus is polyvalent, right? Oxygen plus 2 electron giving you O2 minus. This is polyvalent. We learned that when polyvalent anion is formed, electron affinity is always less than 0. Okay, is always less than 0. So that means it is negative. Okay, so this we have learned even while forming nitrogen ion, polyvalent nitrogen ion, it is negative. Okay, so when polyvalent ion is formed, the electron affinity total is less than 0. Now coming to the D option, which is sodium, giving you sodium ion. Now students, here sodium is a metal. They usually tend to lose electron. So that means gaining electron is very difficult. So that means this will be positive. And E also, aluminum is a metal. Aluminum also tend to lose electron than gaining. So this also will be positive. So our answer is A, B, and C. Okay, so this is our answer, A, B, and C only. That is our second option. This is our 13th question. Okay, and for polyvalent ion, we already discussed electron affinity is less than 0. Now, coming to the 14th one. 14th one is a straightforward question here. You just have to tell which of the following material is not a semiconductor. Okay, so semiconductors are silicon, okay, germanium, all these are semiconductors. Copper oxide is also a semiconductor. Here your answer is, over here your answer is graphite. 14th one, the answer is graphite. Graphite is a conductor, but it's not a semiconductor. Okay. Okay, students, I'll just show you the rest of the next set of questions. So till 14th we have done. 15th and 16th. Please take a screenshot of 15th and 16th. Okay, here, identify the correct statements about p block elements and their compounds. The 14th one, okay. So we are doing the 15th one. So non-metals. Okay. Identify the correct statements about p block elements and their compounds. Non-metals have high electronegativity than metals. So statement A is correct. So we have statement A is correct. Non-metals have lower ionization enthalpy than metals. Low ionization enthalpy. That's wrong because metals tends to lose electron readily. So that's wrong. Okay. Then again, third one, compounds have formed between highly reactive non-metal and highly reactive metals are generally ionic. Yes. That's true, ionic. Okay, that we will learn more about this in our next lesson. The non-metal oxides are generally basic in nature. No, they are acidic in nature. The metal oxides are generally acidic in nature. No, they are basic in nature. So what is our answer? Our answer is A and C only. That is 2 is our right answer. Okay, coming to 16th one. Which of the following elements will remain liquid inside pure boiling water? Now over here, gallium has a higher boiling point. Okay, so it has a higher boiling point. Bromine is a liquid. It has a very less boiling point. In fact, they will vaporize in water. So that's a wrong option. Okay, lithium and cesium. They in fact react. Group 1 elements, they will react explosively with water. So our answer is the first one, gallium is our right answer. Okay, I hope this is clear. Now, just remember for bromine, just remember that they have a low boiling point. Okay. Now coming to 17th question. So this is they're talking about group 13. Okay, react with oxygen in amorphous form to form an oxide, M2O3. Which among the following is most basic oxide? Okay, so here I just share the whiteboard. Hope you have taken the screenshot of the questions. So we are doing the 17th one. 15th and 16th I solved in the PowerPoint itself. Now, metal is reacting with oxygen to give you metal oxide, which is basic in nature. Okay, metal oxides are basic in nature generally. Now, down the group, what happens to the metallic character? Metallic nature increases. Metallic nature increases. Now we have boron, aluminium, gallium, indium, and tellurium. Okay, so this is group 3. Okay, so as you're coming down, what is happening to the metallic character? Metallic nature increases. Okay, So as you're coming down, when the metallic nature, we already discussed in one of the videos, more metallic means more basic. Okay, so the most basic will be which one? Tellurium, TL2O3, tellurium oxide. So because down the group, because tellurium is down the group, so down the group, it becomes more basic because the metallic character increases. Okay. Now coming to the 18th question. The correct order of metallic character, again, the metallic character. So as you're coming down, what is happening to the metallic nature? As you're coming down, metallic nature increases. Okay, here they are not talking about basic nature, only the metallic nature. So definitely we have potassium in the first group, we have calcium in the second group, right? And we have beryllium above. So beryllium will have the least character. Yes. Potassium will be having highest. Then next one is calcium, then beryllium. Okay. So this is the order. Okay. So fourth answer is correct. Fourth answer is correct. And group 1 elements are more metallic or more reactive than group 2. Okay, so that is why potassium comes first and then calcium, though they are in the same period, right? Yes. Coming to 19th one. In the 19th one, which of the following statement is correct? Okay. Statement 1, the electron gain enthalpy of fluorine is more negative than chlorine. First statement is wrong because electron gain enthalpy we just saw a while ago, chlorine is greater than fluorine because of the small size of fluorine. So here the question is which of the following is incorrect? So first one is incorrect. Okay, A is incorrect. B, ionization enthalpy decreases in the group of periodic table. Yes, ionization enthalpy decreases and across the period it is increasing. Third statement, the electronegativity of an atom depends upon the atom to which it is bonded. No, we have the Pauling scale and the Mulliken scale to decide, right? Question that C is also incorrect. Question number D. Aluminium oxide, sorry, option D. Aluminium oxide and NO are examples of amphoteric. No. Aluminium oxide is amphoteric. NO is neutral. So statement D is also wrong. Okay. So what is our answer there? They have asked for the wrong statement. So A, C, and D are wrong statement, which is our fourth option. Okay. So this is our 19th question. So I'll just share the screen for the next set of questions. Okay, students, this is the 20th question. Okay, so the correct order of electron gain enthalpy. Okay, so the correct order of electron gain enthalpy, you have fluorine, you have chlorine, you have tellurium, and you have polonium. Okay, so you have to take give the correct order. So please take a screenshot. Okay, so I'll just take the whiteboard. So we are doing the 20th question where we have the following elements. We have fluorine, we have chlorine, these are in group 7, 17, and in group 16 we have tellurium and polonium, and we have to arrange them in order of the electron gain enthalpy. We know, students, as we are coming down, what is happening for the electron gain enthalpies. It is decreases, and as you are going across the period, it will increase. Okay. Now, that means if you're coming down, if it is decreasing, then polonium will be very less compared to tellurium. Okay. Then you have among fluorine and chlorine, we just studied. We also did a question because fluorine has a very small size. The electron gain enthalpy of chlorine is greater than fluorine. So we have fluorine less than chlorine. It is because of the small size of fluorine. Okay, so more energy is released when chlorine accepts the electron. And fluorine doesn't have any room to accept, and even if it accepts, there will be electron-electron repulsion. Chances are there. So the electron gain enthalpy of chlorine is more than that of fluorine. Okay, so this is correct for the B option. Okay. Now coming to 21st question. In the 21st question, you have assertion and reasoning. You have two statements are given. Okay. The first statement A says the ionic radii of O2 minus and Mg2 plus are same. And the second statement B, this is assertion. And you have the reason saying both O2 minus and Mg2 plus are isoelectronic. Okay, now over here, oxygen and Mg2 plus, they are isoelectronic. We had a question before also related to isoelectronic. Oxygen is 2,6 or 8. It is the number of electrons is 8. It is gaining 2 more. It becomes 10 electron. Magnesium is 12. It loses 2 electrons, 10 electrons. So both are isoelectronic. So this reason, this statement is correct. But is it the reason for the first statement? That we have to check. Okay, the first statement. First, let's check whether the first statement is correct or not. The ionic radii of O2 minus and Mg2 plus are same. Okay, so I'm writing it over here. O2 minus, it has how many electrons? 12 electrons. Okay. And over here, for Mg2 plus, okay, O2 minus, there are 8 protons, and how many electrons are there? 10 electrons are there. For magnesium 2 plus, how many protons are there? 12 protons are there and 10 electrons are there. So the nuclear charge over here is more, right? The nuclear charge is more. So, and also the electrons are lost from magnesium, only 10 electrons are there. So the pull of the positive nucleus towards the electron will be more. I mean, the electrons will be pulled more strongly by the nucleus. Okay, making the size of magnesium 2 plus smaller, because the nucleus will pull the electrons more strongly because there are less number of electrons. Nuclear charge per electron is more. So it will pull the electrons towards each other, right? So the size of magnesium will be smaller. What about the electrons? Electrons have only 8 protons and 10 electrons, right? So the electron pull will be less. So that means the size will be large, bigger. So the size of O2 minus is greater than that of magnesium 2 plus. So that means A is true, but A is false, but so we have D statement, A is false. A is false, right? A is false because why? Because the size of oxygen ion is greater than that of magnesium ion. So A is false, but R is true. Because we saw that magnesium and oxygen, they are isoelectronic. Okay, I hope this is clear. So you can see a lot of questions from isoelectronic is coming, right? So we have done it in one of the videos, the isoelectronic species. Now coming to the next question. Question number 22. Now in question 22, we have element E. They have talked about an element E and it belongs to period 4. Okay. And group 16. The group is 16 of element E. And the valence shell electron configuration of the element which is just above element E. So if this is the element E, it is group 4, sorry. It is in period 4 and group 16. They are talking about the element which is just above element element E. Let's take it as X. Okay, so we have to find out. There are 4 configuration given. We have to find out the configuration of X, which is just above E. It is in period 4, group 16. Group 16 is the oxygen group. Okay, so oxygen, okay, sulfur, selenium, tellurium. Okay, so this is if this is in period 4, oxygen is in second period, sulfur is in third period, selenium is in fourth period. So this is the configuration. This element E is for selenium. So you have to tell the configuration, outer electronic configuration of sulfur. That is the element just above E. That is the element just above selenium. We recognize that the element E is nothing but selenium. So we have to denote we have to find out the configuration of sulfur, identify it among the options. So sulfur, it is 16. So it is 1s2, 2s2, 2p6, 3s2, 3p4. So our option is 3s2, 3p4, that corresponds to A. So this is how you find out the element. Okay. So certain groups like group 7, group 6, and also at least 3 or 4 members just memorize it so that it's easy to solve these kinds of questions. Okay. Now, coming to question number 23. I'll just share the screen so that you can take a screenshot of the third question. So here there are 4 questions. Please take a screenshot of the question. Okay. 23rd question. Inert gases have positive electron gain enthalpy. Enthalpy is positive because the electron affinity is negative. You need to provide energy. They are already stable. You need to provide energy to remove the electrons or, for adding the electrons, right? Now, here you need to tell the correct order of electron gain enthalpy. Yes. Now here, as you're coming down, what is happening to the electron affinity? Electron affinity decreases, right? If it decreases, this is the general trend, right? So that means as you're coming down, it is electron affinity is decreasing, and for the noble gases or inert gases, they already it is difficult to add the electron. You have to provide the energy. Okay, so in this case, helium, neon, krypton, and helium, neon, krypton, and xenon. So if we write down the order, the normal order, if we write, that means as you're coming down, it decreases. So helium will be greater than neon, will be greater than krypton, will be greater than xenon. Okay, but you can say that you can see that helium is very small in size, right? So for helium, it is very, very difficult. So the order will be neon is greater than krypton, is greater than xenon, is greater than helium. Okay, because helium is very, very, very small. So it is very, very difficult to add on the electron because of the repulsion involved. Okay, so this comes to which option? Option number. Oh, I have written the order in the opposite way. So helium is less than xenon, is less than krypton, is less than neon. So I've written in the opposite direction. So this is the right option, right? I have written in the greater than option. So this is our answer, answer number 3. Okay. Now coming to the 24th question, which of the following represents the correct order of metallic character? Metallic character, you already know that down the group, metallic character, metallic nature increases, right? So if the metallic nature is increasing, then definitely down the group, the elements that are down the group are more metallic, and across the period it decreases. Okay, so let's move on to the whiteboard. So we are doing the 24th question here. Here, as you're coming down, we discussed it is becoming more metallic. And across the period, less metallic. So group 1 will be more metallic compared to group 2. Right? So we have beryllium, we have magnesium, this is second group. We have potassium from the first group. We have silicon. Now, who will be most metallic? Definitely it is potassium because it is on the down the group and also towards the left-hand side. So definitely potassium is more metallic compared to magnesium, because as we go towards the right, metallic nature decreases. Then up the group, magnesium and beryllium. Who is more metallic? Magnesium is more metallic than beryllium. Okay, now if we compare beryllium and silicon, silicon is least metallic. So this is our answer, right answer. Okay, this is our right answer. So our answer is first one, silicon, beryllium, magnesium. Yeah, our answer is first one. Okay, moving on further to 25th one. You have to match which element or which the atomic number is in which block. If we talk about first one, 37, atomic number 37. This is A, this is B, 78, C is 52, this is D, 65. Okay, so the atomic number 37, that means argon, it is 18. After 18, 4 is 2, 3D 10, 4p6, 4p6, 5s1. So this belongs to S block element. Okay. 78 is xenon. Xenon is 54. Okay. So I asked you to remember some of the atomic numbers of some noble gases. So it's easy to write down the configuration. Then 4f, 14, 5d, 9, 6s1. Okay. Now here, there may be a confusion. You can use the n plus L rule. Okay. So 5 plus 2, 6, 6 plus 0, 6. But this one is filling the 5 plus 2, 7, sorry. N plus L rule. So it is the D block element. Okay. I hope you remember the N plus L rule. S0, L is, for L, 0, 1, 2, 3, S is 0, P, D, etc. So for 52, we have 4s2, 3d10, 4p6, 5s2, 4d10. I'm just writing down almost the whole configuration so that it's you can relate with the Aufbau rule. Okay. Next one, here it is filling the p orbitals. Okay. So if you have confusion, you can use the N plus L rule. Here it is already, CD is already fulfilled, but P is getting filled. It has 4. It is neither half filled nor it's in between. So that means P is getting filled. So this is the P orbital. Okay, next one is xenon 54. This is 4f9, 6s2. So this is the, so I have told if you have a doubt for F block, you can check whether it is between 57 to 71. So definitely 65 is between. So in fact, here you don't have to write down the configuration. It is between 57 and 71. So definitely this is F block. Okay, so our which option tells us the correct, it is the fourth option, right? Fourth option. A is S block, B is D block, C is P block, and D is F block. In fact, for F block, you don't have to write down the configuration unless, like if it is not between 57 and 71 and from 89 to 103. If it is in this in between this range, you can clearly say that it is F block. Okay. Coming to one more last question, students. Coming to 26th one. The correct increasing order of ionic radii is. Now, here, please remember that chlorine minus, calcium 2 plus, potassium ion, and sulfur 2 minus. Okay, these are the ions that they have mentioned. Okay, among this, calcium ion and potassium ion, they have the atomic number is 20. For calcium ion, it has lost 2 electrons, so it is 18. Potassium is 19, it has lost 1 electron, so it's 18. Chloride is 17, it has gained 1 electron, it is 18. Sulfur, it is 16, it has gained 2 electron, it is 18. So all are isoelectronic. Okay. And for isoelectronic, whenever they ask you to arrange it, isoelectronic is inversely proportional to the charge. So, who has the greatest charge here? Calcium is less than. They have given in less than order. Potassium is less than. Chloride ion is less than sulfur 2 minus ion. So for isoelectronic species is inversely proportional to the charge. Okay, so as the charge is more, they become smaller. Okay, the smallest is calcium. Okay, because calcium, you can say that there are 20 protons, but only how many electrons are there? 18 electrons. So this pull will be more. So definitely they will pull the electrons towards each other and the size is very, very small. The opposite is for the negatively charged ions. Okay. Okay, students, that's all for today. We discussed some past paper questions from NEET and JEE, and you could see that in the question paper, I have mentioned the years also. Okay, so in the next video, we will start with the next lesson about chemical bonding. Okay, thank you, students. Have a great day.